Hello everybody, today we're going to do day 3 notes. This is another way of solving quadratic functions or equations, whichever one you want to talk about. They mean the same thing. So we've already learned how to tell what the solutions are from a graph, and we know how to graph them if necessary, including on how to graph them from the calculator. So we can find all our solutions that way. Today we're going to be talking about solving by factoring. So we learned factoring last unit. This is why it's important, because factoring can actually help us find our solutions to a quadratic equation, finding the zeros basically. So let's go ahead and get into it. To solve a quadratic equation is to find the x values for which the function is equal to 0. There's the 0. The reason we set the equation equal to 0 is because when we're looking for solutions, we are actually looking for the zeros of the function, the x-intercepts. And the x-intercepts are some x value where y is 0. So we always change the y to a 0 so that way we can solve for that. So a lot of times you'll either see it be y equals, you might sometimes see it fx equals, remember that, fx? Not the TV channel, f of x, there we go, f of x. You might see just 0 equals. All of them mean the same thing. They're all set up so that you can find the solutions. They're kind of set up for different methods, but they're all interchangeable. So when you're trying to find solutions, just go ahead and you can change the y to a 0 or just put a 0 on the end of the quadratic and you're good to go. These solutions are called zeros, as I just talked about, and they're sometimes called roots. You're typically not going to hear a whole lot of people say find the x-intercepts during this unit. Okay, you're going to hear solution, zeros, and roots most often. Okay? To do this, the solutions are called zeros or roots. To do this, we're going to use the zero product property. The zero product property, it just says that if the product of two expressions, so when you multiply two things together, is 0, then either one of those expressions or both of the expressions has to equal 0. That's the only possible way you're going to get 0 when you're multiplying, is if one of the numbers is 0. So say a and b are expressions, well we'll say a times b equals 0. Either the a would be 0 or the b would be 0. And that's the only way you would equal the 0 here. Okay? So we do the same thing right here. We say if x plus 5 times x plus 2 equals 0, then either the x plus 5 has to equal 0, or the x plus 2 equals 0. Either of these situations would make the equation true. Remember, and solutions are the things that make it true. So that's why we're going to solve both of them for x. Okay? So this first one, I subtract 5 from both sides, I get x equals negative 5. Here I subtract 2 from each side, I get x equals negative 2. So either of these would work in making that expression true. That's why they are both solutions. Okay? We're going to use this pattern, the zero product property, basically, to solve for the variable in a quadratic. So, 1, get the quadratic to equal 0 and factor completely. That means you might just change y to be 0, or you might have to manipulate the equation a little bit, try to get all your terms on one side so it equals 0. And then you go ahead and factor it using magic X, factor by grouping, GCF, all those things are still applicable here. 2, set each parentheses, each binomial, each factor equal to 0. So you're going to write 2 equations. Typically you're not going to see more than 2, because we should only have 2 solutions, right? Yeah. 3, solve for the variable. You sometimes get more than one solution. So it is possible that you can get one solution though. Or if it's not factorable, you could have no solution. Okay? So here's an example. Find the roots, also known as the zeros, also known as the solutions, to the equation by factoring. So x squared plus 7x minus 30 equals 0. So that one's already set equal to 0. Cool. This one, so I'm still going to use my magic X, GCF, all that fun stuff. I still need to know my A, B, and C, which are right there. And I'm going to go ahead and do it. So first I want to look for is a GCF. Unfortunately, there's nothing in common between a 1, a 7, and a negative 30. I can't take anything out, so I'm going to go straight into my X. And there's no a, well, a is 1 times c gives me negative 30 on the top, and b is positive 7. So what times what will give me negative 30, but what times what will add to 7? So give you a second to think about it on your own. Okay, so if you haven't figured it out, it's okay. Pause the video and try to figure it out on your own without me showing you, because that's how you get better at it, not by waiting for me to give you an answer. Okay, but if you already got it, let's go ahead and keep going forward. The two numbers would be 10 and negative 3. So those are the two numbers I'm going to replace the 7x with. So now I have x squared plus 10x minus 3x minus 30 equals 0. I'm going to do my factor by grouping and group the first two together and the last two together. My first two I can factor out an x, and I'd be left with an x plus 10. My second group I can factor out a negative 3, and I'm left with an x plus 10. Cool. So because I have the same binomial here, that's one of my factors. The other one is the stuff I pulled out, the x minus 3. So x minus 3 times x plus 10 equals 0. So that's my factored form. Now I'm going to set each factor equal to 0. So x minus 3 equals 0, or x plus 10 can equal 0. I don't really care if you use or, and, whatever. You know both of them will be your solutions. So now I'm just going to go ahead and solve. So here I would add 3 to both sides. Here I'd subtract 10 from both sides. So my two solutions would be 3 and negative 10. Those are my answers. Okay? So now you guys are going to try these two on your own. I kind of helped you out a little bit on B, just because I'm nice. My hint was to make it equal to 0, but I kind of did it for you. So you guys can move whichever one you want. I moved these two because there's only 2 here versus this side had 3. Just remember, when you're moving them to the other side, you're using the opposite operation. So this would be minus 2x squared. And you're going to do it with the same term, minus 2x squared from the x squared. You're going to add 4 to this minus 5. Okay, so 2x is just going to stay at 2x. It's not being adjusted. But go ahead and find your solutions to it. And that's the whole video. So you guys can practice that, and we will practice it more in class, and I'll answer any questions you have. Okay? Bye!